Hello, everyone. We'll be starting within a few minutes. Hello, everyone. A warm welcome to all the enthusiastic learners. After the successful week of the Hyperport of Machine Learning and TensorFlow Bootcamp, organized by GDSC in collaboration with Kettle, the official technical committee within the university, I have the pride to welcome you all. Today's or showcase the Machine Learning GDSC and blockchain mentor of Codate community as the captains of the day. Without much ado, I would like to hand over the reins of the session to them. Over to you guys.
Um, Good evening, guys. Am I audible? Ankara? Hello.
Yes, you are audible. Yes,
Okay.
yes.
Hello, guys. This is Arturaba Chakravarti, and today we will discuss about something related to ML, as we have planned, like for this upcoming session, including this, we have planned that we will giving you the taste of machine learning and deep learning and other open CV related things. So I think you guys have some pretty much heavy knowledge from the previous session, I guess. So I think you guys also have some knowledge of ML. And today, so I will start from a very basic ML concept, that is linear regression. For that purpose, let me share my screen. Okay, is it visible, guys? Let me know.
Yes, sir.
Okay, thank you. So today we will discuss about linear regression, right? Okay. This guys are very much interactive. Okay, nice. So, like we have, do you guys have any idea of supervised learning or unsupervised learning? Have you guys any idea of it? Okay. First of all, I'm not a sir. Okay. So call me Dada if you want. So okay. So the ML or machine learning has like three types of machine learning will be there. Like first one is unsupervised. Oh, sorry. Someone is there. Okay. I don't have any prior experience in teaching, so bear with me. So first one is supervised. Okay, sorry. Supervised. Second one is unsupervised, and third one is reinforcement. Okay. So supervised learning, we will use level data that has output. Okay, I'm not going deeper for this. Okay, on this also. So, and unsupervised, we will like have the unlabeled data. By that, our algorithm will understand by themselves. And reinforcement is like when you are giving some type of, like, if you do any task, and after that task, if you give something to learn the model from that type of scenario, the reinforcement learning will be there. So for now, we will discuss about the supervised learning, and from supervised learning, we will discuss about it linear regression. Okay. Guys, I don't have any prior experience in teaching. Okay, so bear with me. Okay. So what is linear regression? When you have, suppose you have two features like height and age. Okay. So if you have two features like height and age, so what do you think if age is increased, the height will also increase, right? So this functionality is called linearity functionality. Like if age is decreased, the height will also decrease. Yes, there will be some sort of outliers, but we will not discuss this. But if you think, like, if I plot something, sorry. Okay. So if I plot something like this, if this is my age and this is my height. So if someone is age like two, okay, one, two, three, four, five, five. So if someone age is like between one to two or three, somewhere between some these data ones, like this has some linearity function, right? If someone if the height of the 1 year old kid and the height of the 4 year old kid will be greater, right? So here these things, this y is our output variable, or y hat can be called as dependent variable, and this is independent. Okay. Okay. So why dependent? Because the height is depends on age, right? If I'm not wrong. So y is a linear function of x. So this is pretty much about it. Like how linear function is this? Okay. If I if I have to draw a straight line or plot a regression line, I will draw like this. Okay. Then this called my best fit line. Okay. So how I will get this best fit line? Okay. So there will be some mathematics. That's why I'm going slow. And okay. So how will I get this best fit line? Right. And for this best fit line, what I have to do? The function, I guess you guys have all already in 11 and 12 in mathematics, you have linear algebra, right? I guess you all have done that part. And the the function of this line is nothing but y is equal to mx plus c. I guess you all know this function, right? For now, for this session purpose, I will go with this equation h theta of x is equal to theta 0 plus theta 1 into x. The whole thing is same. This is I am replacing m with theta 1 and c with theta 0. Okay. And this is my hypothesis, nothing but y, or someone can call, other can call this at y hat. This is my output variable. Okay. So first thing, what is what is this and what is this theta 0 and theta 1 will be? Okay. What does this mean? This theta 0 is nothing but called intercept. Okay, intercept. Okay, so intercept means where the straight line or regression line in the y-axis it intersect. For you can, for now you can see the this line is intersecting in the y-axis in one coordinate, right? 0 comma 1 coordinate. So for now my theta 0 is 1. Okay. And what is my theta 1 into x, or what is my aim? So aim will be nothing but slope. So what is slope? Okay. So what is slope? Slope is, just think about it. If this is my regression line, okay, just give me a moment. If this is my regression line, okay, one unit movement in x-axis, what will be unit movement in y-axis? That will be considered as my slope. We will get to know this very much well in upcoming part of this session. But for now, just understand these things. What is theta 1 and theta 0? What is intercept and what is slope? Because that will be needed in the after this part. Okay. So till now, what we have learned, that what is linear function or what is my best fit line. This is nothing but the whole scenario of linear regression. These things, right? There will be one regression line. There will be some data sets. Data set is nothing but coordinates, right? I think you know x and y coordinates. These all things are coordinates. So this base fit line is nothing but all the function is y is equal to mx plus c. And for now, we will continue this session, and we will take this variable name as theta 0 and theta 1 instead of m and c. Okay. So, till now, it is okay, or anything is hard to understand. Am I audible?
Yes, you're audible.
Okay. Till now, is it okay? This is hard to understand. Any doubt till now? Yes, no, anything will be accepted. There is no response.
Sir, hello, sir.
Yes.
Sir, I didn't understand the theta 0 and theta 1 concept. Can you please repeat that once?
Okay, okay, okay. See, did you
Thank
know
you, sir.
y is equal to mx plus c?
Yes, sir. Yes, sir.
Okay, I'm just taking this variable name. I just changing this variable name with theta 0
Okay.
is it's like c and theta 1 is m. Okay.
And I mean, from where we are getting that theta 0 and theta 1?
You will get this. Just understand
Oh,
now things. Okay.
okay, sir.
Okay. Okay. So I think pretty much you have understood. Hold on. Okay. Fine. So now let's see. I think now you guys know that everything is depends. The line is on theta 0 and theta 1. If I'm not wrong, everything will be calculated on these things. like where the line will be started, where the x-axis will be intersect, it depends on theta 0, and other thing is theta 1. So for now, let's find why why we consider, which line should we consider as my best fit line. Okay, so if my data set is looking like this, I can draw many lines. If I'm not wrong, I can draw these lines, I can draw these lines, but why I consider one single line as my best fit line? Okay, so if this is my data set and my linear regression line is passed near these points. Okay, okay, if this is my data set and my function line go through these points, then see the difference between the actual point and the predicted point. Predicted point means, but suppose I draw one more linear regression line. Okay, if this is also a linear regression, but this is not the best fit line, not best fit line. Okay, see, this is my actual point, right? This is my actual point. But for now, if I consider this line as my best fit line, see the differences. Okay, just wait a minute. See, this is my actual point, right? For this point, x will be here and y will be here. Y is nothing but output, right? For now, for this data point, my output will be here, right? And for this data point, output will be somewhere here, right? But when I take this line as my best fit line, okay, as my best fit line, see the difference between this, then this, the output will be not from here, the output will be here. Like if the my output was 5, for now the output will be 2. The error is very much high, right? If the height is for like 4 years old boy, or no, sorry, 9 years old boy and 10 years old boy is age, right? It's age and height, HI. Okay, so see, if I consider this line as my best fit line, then see, if my, for now the 9 years old height will be somewhere around 2 feet. This is not correct, right? For 10 years old boy or girl, the height should be somewhere around 5 point something or 5.2, right? But for now, my height will be somewhere around 3 or 2 point something. So there is very much high error, right? We will not consider this line as a best fit line. That's why. So how we will what things we should consider? What things we should know to consider a best fit line? Suppose my, so the main thing is we have to reduce the distance, right? See, for these data sets, the distance is very much less. The distance is very much less, right? So for now, we will consider this as my best fit line. Okay, but how we will consider means there will be so many lines, right? If I'm not wrong, there is so many lines to get these things. We have to, each and every, we have to calculate, we have to calculate the summation of every distance. We have to summation these things, these points and these points are always depends on what, theta 0 and theta 1. These things also are theta 0 and theta 1. So for which points we will get this line, So how we will get this line? So calculate, we have to calculate the main thing to get this line. We have to summation the error. Error means the distance between actual point and the predicted point. If for which point, for those points, the distance will be less, we will consider that line as my best fit line. So, what is my, what will be the my error, right? Error is like, if you consider, what will be my consider h theta of x. That means this is nothing but my hypothesis of x, right? This is my hypothesis. I have also already told you, like, this is my hypothesis. This is my, nothing but y. Instead of y, I am using h theta of x. Okay. So if you, if you consider h theta of x the output of new y, or you can call as new y. Okay, new y, because output variable is y, right? This is my output. Here you will get your outputs. Okay, so this is my new y. So this is not a correct thing to pronounce. Okay, consider this as theta, h theta of x. So if this is my hypothesis of x, so okay, this is my difference, right? This is my difference, nothing but the difference between the actual point and the predicted point. Okay, so let me write it in a clean area. Okay, so h theta of x minus y. Till now everything should be okay. Okay, so these things is like difference, right? So we have to summation the difference. I is equal to 1 to m. M is nothing but the number of data set. Okay, the number of data sets, that can be number of data sets. For now, if you see, like, for now we have three number of data sets, 1, 2, and 3. The m is nothing but 3, right? So this is the number of data sets. Okay, so now I want to divide this by m. I want this value, the value, the minimized value, as m, by divided by m to get the average value, and there will be a square. Now you might ask why this square will come. Okay, so just think about it. The difference can be negative sometimes, right? The line, if the line is coming from here, the difference is this, right? This is my difference. Not everyone, not every time will be the difference will be in positive form. So there will be sometimes the negative, in the difference will be in negative form. So that's why I'm considering as square. And now I want to divide these things in by 2. This whole thing, like, you might ask this why 2. In after some time you will get to know why I'm dividing this whole thing by 2m. 2m, I'm already told you about m, but why 2? Like, we have to do the derivation. Okay, like, if you do the derivation of x square, what will be the derivation of x square? ddx of x square. I think you might know that the derivation will be ddx of x to the power n. The n will be here n into x to the power n minus 1. So if I considering as square for negative, to remove the negative part, then I have to remove this 2 also for calculating for simplicity. So I'm, if there will be 2, if I divide it by 2, the 2 will be eliminated, right? That's why I'm taking this by 1 by 2m. This is nothing but called cost function. Okay, there will be some cost. The main thing we have to think, okay, Just give me a moment. Okay. So main thing we have to consider to minimize this value. The value of this thing is called cost function. This is nothing but just try to understand what is it. Like the differences, nothing but just differences between two data points, right? Nothing. Don't just get uh, confused. So this is nothing but just like this is a difference and we have to sum up and then divide by 2. This is just the normal mathematics. Okay. So this called j of theta 0 and this is notation, nothing but notation. Okay. So this is called cost function, and sometimes it is also called mean square error. See, we are doing the mean, right? Average means right, and square. So it is and square. We are doing square of errors, right? So it is also called mean square error. Okay. So this whole things is called mean square error. Till now, is it okay, guys?
Yes, sir.
Okay. So remember this formula, guys. You will need this in upcoming thing. So okay. So now let's just find one
I think
example.
uh, we have
Tell
a
me.
question.
Okay.
Hello, am I audible? Hello.
Yes, 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 yes.
Uh, Here the base fit, we are referring that the closest or the most optimal fit to the specific criterion or objective. Am I right?
Yes.
So in the linear regression part, we are referring the base fit value to get the estimated coefficient of the minimum difference between the predicted value and the main value. Am I right? Or the
Yes.
actual observed value. So
Yes. Yes.
why
Yes.
are we here averaging the values? We could have find in a different way, na? Just a doubt like
Okay, for simplicity purpose, the value will be the summation. If you do the summation, the value will be much higher now. Okay, when you will plot this function, you have to plot. I will show you when you will plot this function from this cost function. The value will be much higher side. But we have to, if we then when we have to go to the global minimum, then we have to go through many iterations. That's why we are averaging this value. Is it okay?
uh, can we just take the least square or the gradient descendant to get the
Yes, yes.
best fit?
I will. Yes, yes. I will discuss this. Just
Okay.
have patience. Okay. So this is my cost function, right? Okay. So let's just get an example of data points, right? Give me a moment. So my data sets is like 1 comma 1, 2 comma 2, 3 comma 3. Okay. This is my data sets, right? And who was asking this question? Hello.
I believe that was Jamila.
Okay, okay, okay. Okay, thank you. See, uh, let's plot these guys. Okay. First, plot these points, right? Okay. Till for now, I'm considering my theta 0 as 0 and theta 1 will be 1. Okay. For now, I'm considering this. So theta 0 means I guess theta 0 will be my intercept. Okay. That means where my y-axis will be intercept. Okay. And theta 1, as we have seen from our formula, what was our formula? Y is equal to mx plus c. You can also apply, but for now I am considering as a is theta of x means hypothesis of x theta 0 plus theta 1 into x. Now, if my theta 0 is 0, there will be no use of theta 0, right? The 0 plus something is like no value. So that's why theta 1 into x is there. The hypothesis of x will be theta 1 into x. So if my hypothesis of x will be theta into x, then what will be my theta is theta of x first coordinate? See, this is my data set. These all are x, y, x, y, and x, y. I'm considering it. I'm considering theta 0 and theta 1 for now. Okay, you have. We will get to know how these things will be calculated. Okay, but for now, I'm just taking this, and this is an like as an example. So if you know the theta 1, what is the value of theta 1? This is nothing but 1. Okay. And what is the x of 1? Like x of 1. What is x of 1? This is nothing but 1. Okay. And what will be theta of x 2? The ith element. Okay. The ith element means ith data set. So for x data set, what will be my second data set? What will be my x? So this x will be nothing but theta 1 into x2, or this data, this point, right? So this will be my output for hypothesis, right? Same a is theta of x3 will be 1 into 3, if I'm not wrong, right? That means this, if these are the values of hypothesis, the same value as my actual points, right? So if I take this line, see, this is my best fit line, my best fit line. Okay. So, so if for now I'm considering theta 0 is equal to 0 and theta 1 is equal to 1. What if I consider, like, let's theta 0 will be 0 again, but for now I'm considering theta 1 is equal to 0.5. Then what will be the value? The value will be somewhere around, like, if, see, hypothesis of x of I. Is it hard, guys? Let me know. If it's hard, then I will explain it again.
No, no, it's okay.
Okay, okay. Okay, so again my theta 0 is 0. So same thing will be happen like theta 1 into x of I, right? So what is my day for what is my current value of theta 1? Theta 1 is nothing but 0.5 into 1. The value will be 0.5. The theta of x of 2 will be 0.5 into 2, nothing but 1. And theta h theta of x of 3 will be 0.5 into 3, that will be 1.5. So for theta, when I'm considering this value, not this value, okay, when I considering theta 0 is equal to 0 and theta 1 is equal to 0.5, then my value will be for what was my x theta of x of I, that is 0.5. Okay, that will be 0.5. And what was my two second variable, second hypothesis, that will be 2. And what will be my third, that will be 3. For this theta and theta 0, linear, the best fit line, the line will be this, but this is not the best fit line. You can see, like, these are my actual points, right? These are my actual point, but this has the error, the distance. Why I will consider this line as my best fit line when I'm getting this line, when my theta 0 is equal to 0 and theta 1 is equal to 1, when for those parameter value, when I'm getting this line, the error is very much low. There is no error, I guess. But for this variable, I'm getting the error. This is my actual point, but this is my predicted point. So there is some value. There is some value, right? So their error will be there. If I'm considering theta 0 and theta 1 also 0, my everything will be lies there. The best fit line or the line will be lies there somewhere between here. Okay, so the height. So now, if you consider, the cost function, what will be my cost function? H theta. Sorry, give me a moment. So what will be my cost function for three data sets, right? If my for j of theta 1, when my theta 1 is equal to 0, what will be the value? I have to calculate, right? 2 into 3. I have to summation also, right? The summation I have to do, like, if my values were 0.5, 0.5 minus 1 whole square, plus second value was like 1 minus 2 whole square, plus 1.5 minus 3 whole square, right? These are my cost function. So the value will be 0.58, not found. So when my theta 1 is equal to 0.5 and theta 0 is equal to 0, the cost function, the value we are getting, that is like 0.58. Let's calculate the cost function for theta 1 when my theta 1 is equal to 1 and theta 0 as my 0. So what we will get, 2 into 3, 1 minus 1 whole square, plus 2 minus 2 whole square, plus 3 minus 3 as my whole square. Right? This is nothing but predicted point and actual point, or actual point. All things are predicted point and actual point. What we are getting from the graph, if you can create. Okay, okay. If you can see that all things are predicted point and the actual point, as my formula says, a is theta of x minus y. Okay, so this is my cost function. What will be the value of this function? Okay, so let's calculate, and this will be 0. See, for this for this theta 0 and theta 1, we are getting the value is 0.58, and for these values we are getting the cost function value is 0. So the main thing for the linear regression, that is, we have to go the minimized value. We have to minimize the cost function to get the best fit line. So, what we will consider? So, what line we should consider? The value of the cost function with 0.58 or the 0. We will consider the value of the cost function with the 0. So, we will consider this theta 0 and theta 1 as my best fit line formula, or the formula will be some like, while theta h theta of x theta 0, and where theta 0 will be 0 and theta 1 will be 1. Okay, so this is not easy to get the line in one chance. So we have to iterate so many lines. By after that we will get these values, right? I'm just considering this as example. That's why I'm getting this value directly. Okay. So if I consider these values as my 0, if my theta 0 and 0 and theta 1 as 0, the value will be what? The value will be j of theta 1 and theta 0 and theta 1 will be 2.33. I've calculated all those things for you guys. That's why I'm getting this value so much first. But you have to calculate. You can go and calculate. The answer will be same. If you did same thing as I am done, the value will be same. So if I'm for now, if let's one more example I will consider. Okay, if my theta 0 is 0 and theta 1 is equal to 1.5, the j of theta 0 and theta 1 will be 1.1.5, I guess 1.58. Okay, so these are the cost function and the data points and the theta 1 theta 0. Let's just merge those things and jot down first. For theta 0, theta of 1, and theta 1 is equal to 0 for the value of theta 1 when theta 1 was 1. Theta of 0, what will be the value? 0.58 when my theta 1 is equal to 0.58, and theta 1 when my these things will be 2.33 when my theta 1 is equal to 0, and the last theta 1 when my proportional theta 1, okay, 1.58 when my theta was 1.5. Okay, these are my cost function, and these are my cost function. So these are my cost function, and along with my theta points, right? So, okay, wait. Just if I lot 1.2, 2.5, 0.5 to 1, 1.5, So let's just plot those points, and this is nothing but this is cost function theta of theta one, and this is my theta theta one. Okay, so let's plot those points, right? When my theta one is one, theta one is one, my the cost function is zero, right? So let's plot this here. This is my nothing but 0 comma 1 position, right? Or sorry, 1 comma 0 position, sorry, 1 comma 0 position. Okay, and when my theta 5.4 0.5 is my theta 1, the cost function, the cost value of the cost function is nothing about 5.8. Okay, and when my theta is 0, theta 1 is 0, the cost function is value is 2.33. And when my theta 1 is 1.5, the cost function is 1.58. 1.58. Okay. Okay. If you join all those points, you will get this kind of curve. Okay. Okay. This thing is called gradient descent. Okay. Okay. So the main goal with the gradient descent, we have to minimize our cost function. And how we will get these values? If if those are the points you get, when we will get this point, this called is global minima. We have to reach till this point. We have to reach this point, right? This is called global minima. Okay. Okay. So we have to reach this point. How we will get these points, right? So for this purpose, we have something as like, okay. Till now, is there any questions? Any doubts? Okay. Okay. So is it understandable? Or easy, hard, anything? Okay. So this is my global minima, and this is called gradient descent. So how we will get these things? Like, see, I'm taking these values, right? I'm taking this sometime theta 1 is equal to 0.5, theta 1 is equal to 0 sometimes, theta 1 is equal to 1.5, but we will not do these things manually, right? And for that purpose, we have like convergence algorithm. Convergence algorithm. What it will do? It will do nothing. Just it will update the theta or the two thetas, right? Theta j is nothing about alpha. Okay, sorry. Theta j minus alpha into dd. Okay. Let's just try to understand what are those things are. Okay. This is nothing but theta 1. This can be, I'm referring as j, that means this can be theta 0 and theta 1. So j is nothing but 0 comma 1. This can be anything 0. Sometimes it can be 0, or when we have to when when we have to update a value of theta 0, then this will be theta 0 colon equal to means continuously updating. These are the notations, okay. And theta z, again this will be, if you consider as theta 0, then this will be also a theta 0. This is learning rate, okay. I will discuss it about after some time. And this is the derivation of theta z, and nothing but the derivation of cost function. The cost function we have seen, like what was our cost function? 1 by 2m, 1 by 2m, summation of I is equal to 2m, and there will be theta of x minus 1. That was my cost function. So how these things will be happening, right? How we will get these values? Okay. So first, this is nothing but this this called slope. Okay. So how it will work? This will work with the gradient descent. Okay. Someone was asking about gradient descent. This is what gradient descent is, and what how it will work. If this is my gradient descent, okay. If this is my gradient descent, if my point is somewhere here, right, and my global minima is here. By saying we can say this is my global minima, we have to reach this point in order to get the theta 1 and theta 0 and theta 1. Okay. So how we will get these things? Okay. So if you consider this point as my current position of theta and theta 0 and theta 1, can we construct a slope here? Can we construct a slope here? Okay. If you construct a slope here, this is nothing but a positive. This is this side. If you axis here, this is called positive side. This is negative side. Every axis has this is positive side. This is negative side. Right. So we will consider this is a positive slope. Okay. Same. If you have some points and you have to go till here, then some points you have to gain, right? But if the values are increasing from here to here, like this is normal x-axis, right? This is y-axis, nothing but y-axis. It's starting from 0, 1, 2, 3, 4, 5, and so on. So if this point is here, and you have to go to this point, like you have to, in order to go this point, you have to add some value, right? But if you can see, like there is my negative sign, right? The something will be subtract from the previous value, right? Something will be previous from the previous some value will be subtract from the previous theta value. That can be theta 1 or theta 0. Okay. But now how we will get those values, right? So we can also construct a slope here, same, right? But for now, this is my negative slope, as this side is my negative axis, right? If you consider axis here, y-axis and x-axis, so you will get those values, right? This is my positive slope. This is my negative slope. Okay. Okay. I'm just clearing these things. Okay. So if I do something slow, do a slope like this, okay, these things, okay, so this will consider my negative slope. Okay. I have not much idea for this slope, but the basic thing is this, okay. So if you if you can see, if your if your value is somewhere here, and you have to put 1 to 3, you have to add some values, right? So that minus negative slope will the value of the negative slope will be some negative value. Okay, and our formula says theta of j minus alpha dt of theta j is my cost function. Okay, so the value of something, the value of minus of this point will be some negative value, right? Alpha into negative value. That means what will be happen? Theta j will plus some values, right? That will be greater than previous theta, and the theta will be go towards the global minima. Understand? Same thing will be happen, or the vice versa thing will be happen this side. If you consider this value as a positive value, if I'm not wrong, okay. So what was my equation or my formula? Theta j minus alpha dd of theta j, and this will be my theta 1 comma theta 0 comma theta 1, right? If I multiply some value, if I multiply some positive value with the negative value, the value will remain negative, right? This side is higher side, right? This side is higher side. If this is like 3 point, this will be 5, right? So this is higher side. I have to subtract some value in order to get this global minimum, right? So theta j minus alpha some positive value. This thing is nothing but this. Okay, some positive value. What will be my output? Theta j minus some value. Okay, is it understandable? Hello. Okay. So what will be my ultimate equation? If I consider this as my theta j, what will be my value? J. When my j, oh sorry, small j is equal to 0, the delta theta 0 will be nothing but 1 by 2m. Right? Theta 1 also. Right? This is my cost function, and we have to do the derivative for this function. What I have to update the value of theta 0. Okay, this is nothing but theta 0 minus this value, this value. So alpha into theta 0 is theta x. If I do the derivative, we will get the theta value, theta 1 value, and same as follows. Okay. So this is pretty much it about linear regression. So tell tell me if you have any doubt about anything. I will try to solve if I know pretty well. Okay. So, Purnima, are you there? Purnima, Ankona.
Yeah, yeah,
Yes,
continue.
Bhaiya.
Okay. So I have done my session and just wait for some Q&A session if there is any query regarding anything. I tried my best to simplify all those things, all those calculation part. Let me know if there is any doubt.
Everyone, please feel free to pop in your questions. We are open up for Q&A session.
I guess that was Jamilul, right? Jamilul, did you understand what is gradient descent now? Like you told me about.
Yeah, yeah, I got it.
Okay, is it okay or anything I missed?
No, you almost covered it.
Okay. Okay, I have one thing to show you guys. Like, give me one. Like, this is not like how gradient descent look like. Okay, gradient descent actually looks like 3D form. I have only one feature. That's why the linear regression is not about two features, right? Not like only age and height. Okay, not like age and height or experience and salary. These are like very much um, normal example for that linear regression experience and height, experience and salary. Sorry. So there will be very much features, right? These called features. These are features, and some these called features, and the output is called output. Sorry, output level, obviously. So based on features, we have to calculate our out. We have to calculate the output. Okay. So for you can, did you know about when you are doing some like house price prediction, or when you are searching for house, there will be some criteria, right? Those are features. The square area, square foot of the house, the locality. Those are features, right? Based on that, in a popular area, the house price will be much higher side. But the same square feet, if you are searching for 400 square feet house in a popular area, the house price will be much higher side. But if you are searching 400 square feet house in a normal or not that much popular area, the price will be lesser side. So there will be so many features. Based on that, we have to calculate output variable. So this is like the 2D gradient descent looks like, but actually it looks like 3D. So let me show you. This is what actually gradient descents look like. And I tried to show you guys. This is not possible for me to draw these things. So yeah, that was it. And sorry for the handwriting. My handwriting, I know my handwriting is not that much good.
No, it's okay. I had a small doubt that you have shown us the gradient descendant one method. So can we also do it in a OLS method,
OLS method, yes, yes, you can do. Actually, in the
like
scikit-learn that was implemented there.
yeah, the ordinary list square one?
Yes, yes,
Can
yes.
you give us an example of OLS one, if possible?
For now, I have not prepared
Jamrul,
for those.
sorry, Arvada, for interrupting. Jamrul will be covering the OLS part in the 19th session. I just got it right. So basically, there are two. Okay, what was Jamrul saying? Sorry for Arvada. I'm just setting a bit. So Jamrul was talking about closed form solution, which was implemented in the like direct formula part, and there is a non-closed form solution that is implemented using gradient descent. So Arvada was talking about gradient descent thing. because while using direct formula or OLS method, the main problem is when the dimension increases, the like accuracy decreases on that part. So Orkut was talking about the gradient descent thing. OLS part, I will be covering it in the 19th session. So please have a bit patient. Okay, Orkut, sorry for interrupting. I'll just like I couldn't keep my thing. Sorry. Okay,
Yes.
continue, Orkut.
Yes. Is there any other doubts? Are there? How was the session? Is it very hard to understand the calculation part? See, in machine learning, there will be some sort of calculation, but is it? Okay, till hard. Okay, so I think there is no query. And this is little hard but understandable. Okay, Ankuna, are you there? Or
Yes, I am. So I guess anyone doesn't have any more doubts. So we'll be moving on to the next session for the day, for which we have Otishman Ray, who is the blockchain mentor of Code8 community. And without further ado, I would like to hand on the baton to Otishman. Here you go.
okay,
Thank you, but I won't take like much of time because I can understand. I have been at your place and खिदे पे sorry भूख तो लगाई होगा सबको. So I would just take a few moments, just show you the coding part because the theory part is almost completed, I guess. And I will be covering the Jamidol OLS part. I will be covering it. Okay, don't worry. If you have any doubt in that session, do feel to say me. And if I go in somewhere wrong, do help me to correct it. Okay. So I'll be sharing the screen right now. Just give me a sec. Okay. Can you see my screen? Yes, no, chat.
Yeah, it's visible.
Cool, 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 cool. Okay, how many of you guys know about like Google Collab? Just be honest. Brutally honest. I don't know Collab. I don't know thing. That's completely fine. How many know it? GTS says okay. Our GTS has raised the hand that he knows. Okay, that's cool. Anyone else? Anyone knows? No, yes, something. Okay, Pushkar knows. Siddhant knows. Okay, some familiar names, I guess. Anyone else? Come on. Let's make this chat interesting. Come on. It's pretty much boring types. Come on. Okay, Aratrika Malik, Ayush Mitra. Anyone else out of 40 students? Okay, out of 40 students, 5 people knows. Cool. No issues. So Arunima will be sharing a video in the group regarding how to install Collab and how to do about in Collab. Just get into it and just hung around a bit. Means you guys will pretty get used to it. Basically, in Google Colab, you guys gonna run your code. Now, you guys learned about the mathematical solutions, mathematical stuff. So, like if you ask me, it was difficult for me to understand at first. I ghumye bota, honestly. I used to sleep when the maths used to come. Anyways, so in Google Colab, you guys have to run your Python code. Now, machine learning can be done in several languages. You guys can do it in C++, Java as well in certain scenarios, and Python is the most common language. We use Python because it is mostly supported, and when like we use C++ when we need it to be faster. Like sometimes the code are like we need the accuracy as well as the efficiency of the code. Then we use C++. So that was a bit okay. Sorry, I blabbered a lot. Anyways, so over here, like Orkuda said about the linear regression stuff. Now over here, I am taking a data set. Now, whenever we are going to do machine learning, we need a data set to work on. Okay, without data set, nothing is there. Like machine learning is all about data. So over here we are taking data set as because the placement season is going on. So I'm taking a data set where there is a CGPA and a package. So we will be taking CGPA, like a person getting how much CGPA, and will predict that person's package. Okay, if I got 6 CGPA, how much package I can get? Okay, with six CGPA I can get, I guess, 3 lakhs, 4 lakhs, I don't know. Anyways, so these are some dependencies we need to work on. Matplotlib is to like plot the graph. Okay, you need like plotting techniques where you need to plot stuffs. Okay, pandas is a library which is used to work with data frames. NumPy is again with handling with arrays efficiency. We'll be having like several videos on this which will be uploaded in YouTube. Surely go and check it out. So let's get started. I will take just abruptly 8 minutes. So yeah, just run the code. Over here you can see there is CGPA and package. Like for 6.89 CGPA in my dataset, the person who got 6.89 CGPA has a package of 3.26. Now, for example, let's consider this CGPA of mine. Okay, I got a 6.89 CGPA, the package is 3.26. Likewise, there are several CGPAs. So we have a data set of approximately 200. Like 200 people are in this data set which have their package listed. Okay, now by using the PLT thing. Okay, now PLT is used to plot the graph. Now PLT.scatter, as we know, x comma y is the way we graph it. Okay, we never use y comma x now. So basically, in this df is the data frame. Okay, now df of CGPA, that means particular. Let's consider it as a like this is the df. Okay, and we are taking the CGPA. That means this column we are taking. Okay, so this is the x part and this is the y part. Okay, now this is for labeling. Just run the code first. Okay, now you can see over here CGPA, this is the x part. Okay, x is over here and the y is over here. So basically this is plotting. It is helping you to plot. Okay, wherever you don't understand, please do like write in the chat box, and also let me know if I'm going too fast, because I understand about the time limits. So that's why I'm just getting a bit fast in this thing. Okay, are you guys getting the points? Like understandable? Sarji, Pushkar, Siddhant. Okay, and okay, three thumbs. Okay, out of 43 thumbs. Okay, I'm doing pretty good, I guess. Okay, sorry. Nice. We are getting good. So now what we need to do is take the x part and take the y part. Now what is x and y? X and y, x will be the independent values and y will be the dependent values. Now what is independent dependency? We'll be covering it in 19th session. Don't worry about it right now. But right now, for simplicity, understand this much. Key x will be the data we need to send into the machine learning model, and what will be the y? Y will be the predicting data. Like y will be like predicting the things. For example, if I give you that this is a CGPA, so y is the predicted value. Okay, this will be predicted. So x is CGPA and y is the package I'm getting. So for example, for this package I'm getting the CGPA. So I have to give x, the y will be predicted. So we are sending this thing into the machine learning model. But first, you need to understand what is this ilog doing. Now, ilog is a property that is used to select rows and columns by index or position. Okay, let me see. So it's a plotting the data set basically. Now, x and y can be used for like plotting, can be used for many purposes. Yes, you're right, but it is not only used for plotting. Like a variable can be used for many things. Now you can use x for doing plus minus, x and y for plus minus. You can do x and y plus for many stuffs, not for many operations. So yeah, you're like partly right, Chandra.
So what exactly
Hmm.
is DF? Like in the chat box they're writing data frame. So could you repeat that part once again?
Let's show data frame. Now data frame concept that will be covered in YouTube video. Okay, but I'm still giving you a glimpse of it. Now, data frames are nothing but aged datas are there now. Now, these datas are represented in a array format. Now, if I show you an array format, obviously it will be like complicated for you guys. So nothing, pandas did something that like for some people it's like complicated. Now, if I do this thing with you, give me a second, was it data? Now, basically, this is in this format. What does pandas do? It completes it into a table format. So that is what it is doing. Data frame. Data frame is nothing. It is converting into a data format, like particular in a table format, so that it is easy to access the data. Am I a bit clear?
Yes, yes. Thank you.
Sorry. I guess Orkoda still taught better than me, I guess. Anyways. Uh, so X over here, we are taking the particular frames like datas. Okay. So we are selecting the datas from rows and columns. Okay. So X and Y are given over here. Now what we are doing, we are passing these datas into trend, test and split. Now before passing the data, let me say what is this trend, test and split. Now, train, test, and split. What machine learning does, if there are 100 of datas, what it will do, like for example, I thought assigning 80% of data to go into the machine learning model, saying, Dada, this is the 80% of the data, analyze this. So the machine learning model, what it will do, it will analyze. Ki, Acha, for 10 CGPA, the person is getting 10 lakhs. For 8 CGPA, the person is getting 7 lakhs. So by this thing, it will analyze 80 of the datas. Now, after analyzing the 80 of the datas, now machine learning model will try to see if any new data is given to it, will it predict it right or wrong? How much accuracy, like how much accurately it is predicting that data. It will see that. So for that thing, in a data set, we are like we will just split the datas into train and test. Okay, and then we'll be passing it into the linear regression model. Okay, now we'll be importing the regression model from the sklearn thing. In the 19th session, we'll be making the linear regression model from the scratch. Now over here, like just because Orgoda was saying, so I just thought to give you the glimpse of it. And in 19th, we'll be covering the like code from scratch actually. So over here, we are importing a linear regression model, sending it into the X-train and Y-train, like sending the training data set. So over here, what we are doing, we are like splitting the data into 0.2. What 0.2 means is like test size is 0.2. That means if there is 100% of the data, then 20% is the test size and 80% is the train size. Okay. And random state basically controls the hyperparameter in the trend test and split. Okay. Now hyperparameters we'll be talking it later again in the 19th. Anyways, so it is going like we are now importing the linear regression model into a variable LR. So we are taking the linear regression model from the like sklearn like scikit-learn thing, and there and then we are keeping it into a variable named LR. Now in LR, what we are going to do is to fit the data. Now we have X-train, we have X-test, sorry, we have X-train, we have Y-train. Now we have to fit the data now in the machine learning model so that the model will run the code. For like it's like if a car has an engine, you have to feed the engine with fuel. Otherwise, how will it work? Likewise, linear regression model is the machine, is the engine. You're feeding it with data. Now, by feeding it with data, what you're doing, you're making the linear regression tune, like that model tune according to yourself. How you want to work with, how you want to work with it. Okay. Now, let's first see what are the X-test and Y-test data right now. This is the X-test data. This is the Y-test data. Okay. Let's predict the values. So we have already, so I have already learned, like run the code beforely. So this is the linear regression model LR, the stored in variable. Then we are fitting the data into X-train and Y-train. So this is the regression model which has been compiled. Okay. Now X-test data, Y-test data. Okay. Now we are predicting the data. Okay. Now, obviously, we have to predict the data and see is the code is running it or not. Like it can be wrong, it can be right, but we have to understand one particular thing. A linear regression model doesn't give you actual data; it gives you predicted data. For example, for 10 CGPA, if the data set has 10 LPA, it won't give you 10 LPA. It might give you 11 LPA. It might give you 9 LPA, or it might give you 10 LPA, which is in a very rare circumstances. Okay, so that is the thing. Now let's see what is the like data predicted right now. Now how we, what is this thing over here? What we are passing is x test of I log 0. That means in the x test we're passing the first data. The first data we are passing. We want to pass the first data. That is like everyone has learned our list, arrays and sort of stuffs. Like array indexing, everyone knows now. Just comment it down. Array indexing. Mm-hmm. So in array indexing, what is that? Okay, 0 is the first data, 1 is the second data, 2 is the third data. Likewise, so 0 is the first data. Now what happens? I guess you have seen. So you will be like, okay, so just pass x test in bracket 0. Why we are doing ilog at 0? Then like we can do x test dot ilog in bracket 0. Why we are doing values dot reshape? Now what is the problem over here? When we are predicting the values, it is in the shape of like 1 comma 1. With the data we are passing, it is a one dimension. But the predicting values, it is expecting a two-dimensional thing. Why we are expecting 2D? Because over here you can see over here what we can see, it is a 2D data. So basically the model is assuming it is a 2D data. So it is asking you give me a 2D data. I don't want a 1D data. I don't want this particular value. I need this full particular row. I don't need this particular value. I need the full particular row. So what it is doing, so what we have to do, like to send that particular data, we need to reshape it and reshape it into 1 comma 1 such that it becomes a 2D data. Okay. Now if we like remove it now, like it will get an error. Let me show you. It says reshape your data either using array.reshape if your data has single feature, or array.reshape 1 comma minus 1 if it contains single sample. Simply means ilog. What's ilog? Ilog is basically selecting the data. So wait a minute. Ilog is a property that is used to select the rows and columns. Okay. The particular row, for example, you need this particular row, this particular column. Like in this particular column, you need this particular row. So you have to write like that thing. Like over here x is ilog, that means we are selecting all the rows from 0 to 1. Okay, like it's from 0 to 1 we are selecting all the rows. Okay, Pritesh, I'm clear. I can get into it again. Don't worry about the dinner part right now, but if it's clear, for everyone it is clear. Cool. Anyways,
Sir, why is it -1 and 1 for single feature, and I guess for single data is 1 and -1?
nice one. Nice question. Now, over here, what is -1? Like, you guys know what is -1? For example, this is the array. Okay, I just wrote the answers. Sorry, just give me a sec. Anyways, you guys know the answer. Anyways, the thing is that whenever we do this thing, -1 is nothing, but it is counting backwards. So -1, this is -2, -3, -4, -5. Okay. Now over in Y, we need this particular package thing. Okay. We need this thing. We don't need like the CGPA part. So what it is doing, it is selecting all the rows, which is in -1 column. -1 column means the column before CGPA. And what is before CGPA? That is this one, package. Okay. Is zeros -1. Like what does 0 do? Like it is a position. Like 0 position is like, for example, let us assume there is an array of 1 comma 2 comma 3 comma 4 comma 5. Okay. It has position 0 1 2 3 4. Okay. Now what if it says give me a position of -1? it does nothing, but it reverses and comes to 5. Give me a position -2. It reverses and comes to 4. Means it is a reversing. For example, if it is -1, it will come to package. If it is -2, then it will come to CGPA. If it is -3, again it will go to package. Okay, you got this point.
Yep.
So in Y, what we are doing, we are sending the package value. We are sending the package column, and in X, what we are doing, whatever features are available till package. In this case, there is only CGPA. But example, there is CGPA, there is experience, there is class performance, there is more other features. So we will be sending all that particular rows, all the particular columns into X. Okay, so we'll be sending all the particular column into the X, and Y will be the predicting. What will be the values which we will be predicting? So Y over here is what for the column? Y will be the package thing. Okay, for here we as we have only like one CGP, sorry, one column. That's why we are taking like from 0 to 1. You can see this is the rows. It will select the rows. Okay, like the left and right side of the column is the starting point and the ending point. The starting point is this, and the ending point will be here. Likewise, the starting point over here is 0, and the ending point is 1. So it is 0 and it is 1. Okay. Now what it does, it comes to again 0. Like whatever the position is, it takes the position start, whatever the value you have given, end -1. It goes till this position. If you give 1, it will go from 0 to 0. That means it will take only this thing. If we had like more 2 to 3 features, and it won't, like the end will be 3, so it will be taking 2 columns. Like 0 to 3, it will be taking 2 columns. That means 0, 1, and 2. So it will be taking 3 columns. So it will be taking 0, 1, and 2. Okay. So like this, it works. Am I clear? A bit clear or something? Any more doubts? You guys can open up. I'm trying to cover it as fast as I can. Guys, okay. Are you guys sleepy? Sorry. सब सो गए क्या? 35 people are right now. Okay. No issues, I understand. Okay, so let's without any further thing, let's just print the value. Now over here we are sending this particular X test. Now for 8.58 CGPA, what is the Y test? For 8.58 CGPA, what is the Y test? It is 4.0. Sorry, CGPA for it is the package 4 LPA. Okay, you guys can see this is the index number. Okay, so for 8.58 CGPA, what we are getting 4.10. Like it is the actual data set. What is the predicting value? What we are getting, it is giving us 3.89. It is not that good accuracy, but it is okay accuracy, I guess. So it is giving us that person would get give me a sec. Will get a 3.8 LPA according to my linear regression model. Okay. Now the more you have the data, the better your model is. Okay. Also, you have to do some fine tuning, and there are other certain things which we can do to increase features. But obviously, the data is the key. Like I will be sharing you a story at the end of the time. Okay. So now, Orgoda said about like a straight line, linear regression line. Okay. Now let's see in actual case, in actual linear regression model, the line. Okay. Now how it works. This is the line the model is giving to me. Okay. Sorry. So this is the actual linear regression line. That is the model is giving it to me. PLT.scatter. I guess you guys know this, and over here you know this. The new thing which is being introduced is PLT.plot. What PLT.plot does, it is just plotting the data. Okay, like see, there is the line it is plotted. Okay, now what in plot, what we are passing, that go to extreme, like all the extreme values. Okay, into the LR.predict extreme. So it is just predicting the extreme, all the dot, all the thing, and is connecting the line and giving us a straight line. Because it is a linear regression model. When you guys will work with any other algorithms, You guys will see many other curvatures. In SVM, there are classification problems and all. So there are many things. Okay. In linear regression model, we are getting this line. Okay. So that's the thing. Now, what is the backstory behind it? Like, obviously, you guys will be like, "अरे चल क्या रहा है? पीछे क्या चल रहा है?" अब तो like एक regression model lie, like give the data and there's the working. Like, how will I understand what is working behind it? So, what is actually working? It is going to back to mathematics. Okay. So, have you like done this y is equal to mx plus c, the straight line equation and all? Y is equal to mx plus c on guys. Okay. So why? So what is m? What is m? What is m? अरे अभी तो बोले वो है. What is m, guys? Come on, come on, come on. You guys know it. Don't Google it. Ah, okay. Chandra slope. Okay. And what is b? And what is b? Fast, fast, fast. What is b? It is constant, na? Intercept constant. M is the slope and b is the constant or the intercept. Okay, but we know. So from here we are finding the m of this line. Okay, it's LR dot QF. You will get the slope or the coefficient. Okay, and LR dot intercept will give you the like intercept or the constant. Now, if we see the backstory behind it, now let us take this particular CGPA. Now, what I said, CGPA is X and Y is the package. Okay. Now, we are predicting the package. What does that mean? We need the Y value. Okay. So, Y's value is like what is the formula? Is equal to mx plus c. Okay. So, we got m from this particular model. We got b from the model. Now, we are just switching it the data. 8.58. Let's see what is the answer it is giving to us. It is giving us 3.8911. You guys can see it is the same output it is getting. So this is the maths which is working behind actually. Now if you just change the data and if you get some random data, my model its output is it will give you 4 LPA for a 9.5 CGPA. Now if you give 900 data, it will give you some LPA, this much LPA, but in like it is not logical. Na? You can't get this much of CGPA. You can't get this much of LPA. Obviously, you can get it if you are some millionaire or what. But right now you can get now. So we have to put some constant in it. If you put constant in it, then obviously it will work according to that manner. So now we are not putting constant, and it is just going here about here and there. So right now, let's keep it into 5 CGPA, and you guys will get 1 LP package. Don't get a 5 CGPA. Anyways, so that's it. Anyone has any doubt regarding this? I went too much fast. I went too much like a train speed. I know people won't get some stuffs, so you guys are open to questions. Whatever you need to know. I'm sorry for getting a like average teacher. Anyone has any doubt?
Ashok, could you tell about the test and the train once more? Like tests are the examples and trains that are predicted. Is it like that?
Okay. Pati Katha, taken in layman terms. There are like 100 data. What the model needs to give me a certain amount of data. Now in a data set, you can't make a new data set now. So what you need to do, the particular data set you got, you need to split it. Okay. Split in such a manner, the maximum number of the data is going into training. Because if you don't give the like enough data to training, it won't give you a better model. Okay. So if you have 100 rows, you have to give like a good amount of data to train. And for testing, because all the time you can't go and like just write over here, give me a predicted value this, give me a predicted value of 10, give me a predicted value of 11. So what they do is they split it the data into two several parts so that it tests the data accordingly. I am training the 80% of the data, and this is the model I've generated. Now test it whether the model is working okay. You can see over here, the model isn't giving us the accurate answer, but it is giving us a close to accurate. The accurate answer is 4.10, but our model is predicting how much? 3.89. It isn't the right answer. It's giving us the predicted answer by using this formula. So, what in xtrain and xsplit does, the xtrain, if we give a test size of 0.2, what it will do? It will split the data where xtrain will contain 80 amount of x rows, y train will contain 80 amount of y rows, y test will have 20 amount of y rows, and y train will have 20 amount of other. Sorry, this case will have 20 amount of x rows. মানে পাতি কথা হচ্ছে, if the index are from 1 to 80, 1 to 80 will go to like in a shuffling process, like the random data. You can see over here, they are not like in an ordered manner. Okay, there are 200 data, they're not in an ordered manner. Random data have gone to xtrain, and random data from the data set have gone to xtest. But there are 80 amount of data and 20 amount of xtest data. 20 amount of xtest data and 20 amount of xtrain data, which have been shuffled and went. They are not in a synchronized manner, but they are going just to like xtrain will go into the regression model, and the xtest we will be predicting the data. It's clear? Or at any particular point you're not understanding?
Yes, clear.
Chapole text me. Okay, cool. Anyways, okay, that's it. Anyone has any more doubt? Chandra asked pretty good questions. So
Can you please go the backward a little bit?
Which one?
Where the output was showing in the back? No, not that back. In first one, when you showed the output one, the CGP and the package one. Yeah. Here we can see that the 6.89% got 3.26, and here we can also see that 7.82% got 3.25. We got the lesser one. So in the back end, are we putting the logic that the more CGPA, more package, or it is like random?
No, it is not a logic. In backend is a shuffling. Over here only the random state is coming. It is a shuffling like anything. It has another concept in the back. Okay. In random state, if you give the random state 0 now, the shuffling will go haywire. So it's a shuffling. There is not a particular algorithm which is following. You can see over here, like in the xstat, it has 8 LP also, it has 6 LP also, it has 5 LP also. You can see over here. You can't see over here like only 3 LP. In xtrain there will be, wait, let me show the xtrain part also. It will be clear to you, I guess. There's a particular algorithm. It is like, you know, the random function, the random.rand.
Yeah.
It doesn't use some particular algorithm to follow. See,
actually in the beginning you said like more CGPA, more package, so that's why I got a little bit confused.
Oh, sorry, I just meant more CGPA. Like I was just explaining the data set. If you have more CGPA, obviously more package, but according to like whatever data set we will be getting, like that. I'm just explaining like what happens in scenario. If you get more CGPA, there will be more LPA, as you can see. but there are certain scenarios that this person got 9 CGPA, but he's getting like between 3.5 and 3 LPA. So there are certain errors, and by this only the lineation works like that. Okay,
So how do you make it more accurate?
how do you make it more accurate? So the thing is, there are several models which you work with. Uh, this model uses the OLS method. Okay, now it has a কি বলে ওটাকে? Mathematical techniques. So we'll be discussing in the 19th. এখন আর বেশি টাইম নেবো না because it's already 9:30. So I like sorry, but I will take it in 19th. But increasing accuracy. Obviously, remember this one thing, that there will be certain data which will be exception. Okay, like this point is an exception. You can do with it, but every line is over here. Now to increase the accuracy, you either have to get a good amount of data set, or you have to like do some functions, like play around with functions to increase the accuracies. Okay, so there are certain functions we'll be discussing, which we might discuss. Okay, so which increases the data, like which increases accuracy. Okay.
Okay.
Okay, anyone else? না সবাই ঘুমিয়ে পড়েছে রে। অঙ্গনা, take it up. Everyone has slept, I guess.
Guys, we are up for Q&A session. If you have any more doubts, please feel free.
And also, I just wanted to ask who is this Mridul Kanoria? I was just curious. He's not in the session. Anyways, no, he isn't. Anyways, I'm gonna continue. Sorry, I just said too much curious about this part.
That's okay. And with that, we come to day two's end of the Machine Learning and TensorFlow Bootcamp. And I thank you, Ochishman and Orgoda, for the wonderful session. It was really informative. And all of you will be soon circulating the feedback form. Please feel free and fill it up. Thank you.